development of the current engineers, yeah, what is happening now, and also the role of the engineers for future. Yeah, where are we heading? Which area we should go? You know, are we going to continue the rest, you know, the earlier technology that developed, or do we have to do some additional changes drastically, you know, or expeditiously, you know? And then the last part I think is very important, yeah, is the characteristics of a reliable engineers of the future. What type of character that we need to have for the engineers of the future in order to continue to contribute to the aerospace industry? Yeah, and then our last part, little bit on the conclusion. Yeah, and just for information here, yeah, Mr. Bean is actually an electrical engineer. Yeah, graduate from I think Oxford. Yeah, so don't look at Mr. Bean as a comedian. He is an engineer as well. Yeah, engineers are multi-capable. Yeah. Now, this is the slide. It's not about me. Yeah, it is a slide about the acknowledgement to my parents, yeah, to my mother, to my father, and then also to my schools, my mentors, you know, the fellow engineers who have been here with me, yeah, since day one I joined the aircraft industry. You can see all of them here. So in 1919, you know, I studied in MBS KL, yeah, and I joined Malaysia Airlines as a trainee artisan. Trainee artisan is actually a trainee mechanic or trainee technician. I started there. I left Form 6, yeah. I left Form 6 science stream, yeah, to do a trainee artisan, to go through a trainee artisan scheme for 3 years. Then I became a trainee. I became a 737 artisan, and then within a very short while, very short period, 8 months, under the guidance of Tuan Yuze, Rashid Sharif, Christopher Denker, and to a certain extent, Dato Sri Azharuddin, who failed me, you know, when I submit for my exams. Those are the people who gave me the guidance and inspiration. Ricky, where have you failed? Which part you did not do well? This is where you need to focus. These are the mentors that I acknowledge them, who have actually given me the guidance throughout my career. Yeah. So in 1995, I left Malaysia Airlines and I joined EVA Air as a station engineer. Got my additional training on the even more aircrafts. And then in 2002, I left EVA Air and became in the, what they call it, a KLM station engineer for 4 years, from 2002 to 2006. Yeah. So my earlier stages of my career as an engineer was actually in the airlines. Now in 2006, I decided to join still the engineering work, but now it is actually the corporate jet. Corporate jet means business jet. Business jet means private jet. Generally, it's private jet, you know, and became the head of the engineering and services company. So from there on, I got my additional training, yeah, on the corporate jets, Cessna Citation jets, the Gulfstream jets, the Bombardier jets. Yeah, those are the additional training. So you can see it is very interesting for an engineer in his career, because as we grow our career, right, you see that new aircraft comes in, new technology comes in. We will also be involved, you know, in the training. And then of course, I also have my mentor with me. I also have, apart from the industry mentor, I also have academic mentors. My academic mentor is actually Professor Engineer Dr. Rahim, who is actually has been guiding me to be part of the academic world. Yeah, and also he has also shared his advice to me how to be a professional engineer. Now, in the last 33 years, being an engineer, starting from the very technician level, I find this profession as a very interesting, very challenging. Yeah, very challenging. I've traveled to many parts of the world, all at the expenses of the company. Yeah, I don't even have to pay a single cent. I used to advise my children and let them know that If you want to travel for free, stay in the nice hotel, fly in the one of the best airlines in the world, be an engineer. You know, I used to encourage my children like that. Of course, now my daughter is going to be a civil engineer in Japan, yeah, in Japan. So the career of engineering has always been very, very interesting. Very interesting. We have goods, we have downs, we have happiness, we have, you know, sometimes we have frustrations, but those are the fun of being an engineer. I had a lot of fun in the last 33 years, yeah, and I still enjoy it even till today, yeah. Now, let's go back and see how did the engineers come in? How did the aviation started? How? When did actually really started? Actually, the history of aviation started about, you know, more than 2,000 years ago. You know, 2,000 years ago, the aviation people start to, you know, want to fly. And the first thing they actually designed or developed was, the easiest one is to just, you know, build the kite and then fly the kite. You know, I don't know, have any one of you during your younger days even fly a kite before? Build our own kites and then we fly. I myself, during my time, I stay in the Sungai Buloh New Village. We are actually farmers, and we have a big, you know, big neighbors' land, you know, where we actually go and build our kites and then start flying. This actually came from the ancient China time. So you can see even from thousands of years ago, people has been trying to fly. Yeah, so of course they cannot fly immediately because human being has no wings. So they started off with a kite first, and then from the kite slowly, you know, they make gliders, you know, then they make airplanes, you know, then they make a subsonic jet, supersonic jet, and then hypersonic jet, you know, and you know, at the time they even built the balloons, you know. Even if you look at the picture here on this side here, my arrow is pointing. This is basically a kite, yeah. Kite trying to carry a person in a basket. This is a huge kite. Can a kite carry a person? Can a kite carry a person? I'm not sure if you have seen an incident, I think about 2 or 3 years ago, where, you know, they were having a kite festival near to the beach, and one children or one child was holding the what they call it, the kite string, you know, and his accessories, and then for some reason he was lifted off the ground. So which means that if you build your kite strong enough, big enough, yeah, putting in the right engineering what they call it, structures, you know, connection joints and all those, it can actually fly and carry you up. So the ancient time people already have this knowledge at that time. But is it practical? We are not sure. Yeah, we are not sure. Yeah. So we look at the history, earlier history, recorded history. Yeah. After the new Chinese people, who are the people who actually had documented? We are starting to talk about design. How can we design something so that human being can fly like a bird? Who came up with the design? We only thought about it, but then there is one person, and you know, it's Leonardo da Vinci. Leonardo da Vinci actually born in the year of 1452. We are talking about 600 years ago, almost 600 years ago, 600 years ago. He is the person, he is an engineer actually. He's an artist, painter, you know, and also an engineer. He was the one who came out with the idea about flight, man flying. And you can see from here, from this picture here, yeah, this is how he drew the wing that can be attached to a man so that he can fly. Those, at that time, those were the aspirations. The engineers, you know, thought about it, how to get human being up in the air. And he came up with a glider, yeah, with the wings, yeah, gliding wings. So after that, what happened? After that came, yeah, we see here the Wright Brothers, but I'm not going to touch the Wright Brothers here first because I'm going to touch it later. But we look back and see what we enjoy today. We enjoy nice holiday in Europe, you know, in America, in Australia. It's exciting, right? But nowadays, how many people really go on a ship, you know, go on a ship and then travel to UK? No, right? Majority of us fly in a nice 787, you know, A380, probably A380, you know, and fly to Europe, to fly to Australia, you know, to enjoy a nice holiday. And then when you're in flight, you know, the aircon is so nice and comfortable. You know, you have good food to serve on us. Yeah, you know, we just click one bell, just one click and call the cabin attendant and say, I want a hot white coffee, you know, that kind of things, you know. So it is a lot of excitement today that we enjoy. Yeah, but remember, all these that we are enjoying today, the holidays, our children is able to go to overseas to study, comes from the very, very foundation work of our initial pioneer engineers, our past engineers who have suffered a lot, yeah, who have sacrificed a lot in order to build the initial machine that can carry human being. That is the excitement that they have. Then there were a lot of challenges, yeah. Now let's talk a little bit about engineers who are involved in aircraft development. What are the engineers? What type of engineers are involved in aircraft development? It's not just only aerospace engineers. There are thousands of engineers. For example, if we were to develop an aircraft, for example, a 747, you know, if we were to develop a 747 from scratch, from white paper on a clean sheet, thousands and thousands of engineers are involved. What discipline do they come from? We have mechanical engineers, we have electrical engineers, we have electronic engineers, we have chemical engineers, we have aerospace engineers, aeronautical engineers, and eventually we also have the maintenance engineers after the production of the aircraft. These are all the various fields where the engineers are involved. But where does these engineers come from? You know, they are able to build rockets, they are able to build the landing gear system, they are able to build a pressurized vessel, you know, for the airplane, structurally strong, fly 50,000 feet, no issue, everybody is safe. Where do they come from? They come from science stream students. They come from science stream students. Now, the science stream students are the source of engineers, the source of doctors, the source of scientists, the source of physicists. Now, of course, today we are talking about engineers. So engineers are required, are very crucial to help make life better. Make life better for the people in the world. Why? Because they develop solutions. Now, human beings want to fly, we cannot fly. We cannot fly. How? The engineers will sit down and develop a solution for it. How are we going to get to fly? So the solutions include, yeah, the solutions include, you know, designing shapes, you know, come up with materials, come up with mechanical systems, come up with electrical and navigation system, you know, come up with the radio systems, you know, so that we can actually build a machine that can fly in the air. That is what the engineers does. So without the engineers, we don't have this machine. Now, apart from that, the aerospace engineers have to come in as well, because why? Aerospace are very good in aerodynamics. Why do they have to, the aerospace have to come in? Because the aerospace engineers will manage the forces that is acting on the plane in flight, on ground, in turbulence, give control to the pilot, establish the autopilot system, the flight control system. You know, these are the things, you know, the aerospace engineers have to come in. And then, of course, the last part, the aircraft, the maintenance engineers, you also have to come in, because why? After the aircraft has been produced, we need you to maintain the aircraft and systems according to the design specification of the systems. This is actually very much, I am very much involved in the last part. I myself started off as the maintenance engineers, and it is so interesting because I'm in a maintenance engineers, because I go deep into the system, I get involved in troubleshooting, I get into the fuel tank, I get into the, what they call it, the flight control system and all those. I get to see in depth, you know, about the airplane design and the specifications, and it is fun. You know? Why? Because test flights, yeah, test flights. I've been involved in many test flights. Stall the airplane, make the airplane go into a buffeting stage, you know, stall it, drop it, see the aircraft recover nicely or not. Those are the maintenance engineers. We are actually more on the front line, and it is very, very enjoyable. And once we are satisfied, the maintenance engineers are satisfied with the plane, yes, we will actually certify the airplane and release the plane as airworthy, and also let it continue to fly. So if you're talking about engineers, there's so many types of engineers that is involved: mechanical, electrical, you know, electronics, chemicals, you know, materials, all are part of the engineers, what they call it, role in aircraft development, many of them, yeah. Now, this is something that I want to highlight. Now, you see, this is a telegram. I believe most of you have not seen a telegram before in the modern days, because we have emails, we have a WhatsApp, you don't see much. But when I get my recruitment test examination in Malaysia Airlines back in 1989, I did not receive a letter, I received a telegram similar to this telegram here. Now, this telegram is very special and it's very historical, and it is kept actually in one of the museum in US. In US, you look at, I read this content, yeah. If you look at the content of this, my arrow here, successful flight this morning, yeah, all against 21-mile wind. Started from level with engine power alone, average speed through air 31 miles, yeah, and then longest, yeah, 57 seconds, yeah, 57 seconds. Informed press, yeah, informed press, home for Christmas, home Christmas. So it is a very condensed message that was actually being sent by the Wright brothers to who? To their father. You see, when the Wright brothers first tried so hard, managed to flew, I don't know how many bones that he has broken, how many sprained ankles that he has, you know, but when the flights were successful, you know, all the effort, the first person that they contact to is their father first. That is the characteristic, one of the very strong virtue of an engineers. We never forget our parents as an engineer. So Wright brothers immediately send the message to the father, and then Wright brothers at that time, when they were testing the flight in the Kitty Hawk, when they were flying their Wright flyer, there were press people there. What, you know, there were press people who was trying to following them. Why didn't the Wright brothers say that, oh, come, I'm going to make an announcement. All your reporters here, come, I'm going to make an announcement. No, Wright brothers knows that the respect, for the father, the virtue of the father, this announcement has to be done by the father. This is how an engineer's characteristic have. We think of our parents. We do not want to be sorry with for our parents. We do things that can make our parents proud. We do things, we design things that can help the society, not damage the society. We solve the problem of the society. We don't want to tarnish the image of our parents. That is the very first character that we learn from the Wright brothers. Many years ago, I think about 4 years ago or 5 years ago, I was attending this final year project award, in one of the local universities in UPM actually. And the dean at that time was Professor Dato Saleh. Professor Dato Saleh, some of you might know him. He's actually the dean of engineering at that time. And it was an aerospace engineering final year project. And I was actually being invited as one of the panel judge. So during after the judgment, marks has been given, and then the announcement of the prize winner came. The announcement of the prize winner came. And Prof. Saleh, during the stage, he congratulated all the students. But the touching part is he advised the students that, remember, today, your success as an engineer today is very much attributed to the sacrifice of your parents. Do not forget it and always remember them. Make them proud. This is how Prof. Engineer Saleh, he's also a professional engineer. You see, these are the mindset, the virtues of an engineer. We should carry this kind of virtues together, and pass it on to the next generation. Never forget, as engineers, we never forget our parents. Okay. Now, this is part of the slide, part of the records, a little bit of the trailing line from, thousands of years before until the year of 1783. In 1783, people attempted to fly, and then that time they uses balloon, hot air balloon, to actually lift the human being up. They have a balloon, and then they have basket at the bottom, and then they have a ignition source and fire source. They can actually hot heat the gas, so that actually the gas actually go up. There is still these practices, for recreational in the Europe side. We still have it. But that type of flying is still not sufficient. Human being continue to actually wanted to fly even more. So you can see here, as the graph actually move forward, you can see there's 1891, 1485, when Leonardo da Vinci drew, the sketches, how a human being can fly with the wings, attached to the human being. And you can see in 1891, Otto Lilienthal, he's an engineer, he's a German engineer, and he developed, he put what was drawn by this Leonardo da Vinci, and he actually make it and fabricate the wing up. He fabricated the wing up, and actually it became a glider. And actually he did manage to fly, but only as a glider. The actual real heavier than air flight, machine propelled flight, it is actually still the Wright brothers. Let's go and see. Now you can see on this graph here how Otto Lilienthal designed the wing of his glider. You can see it looks very much like the wings of a bird. You can see very much of a bird. So he designed and structured it so that it can actually have the width and the breadth of a wing. And he flew successfully a few times, but he died. He died in one of the crash. He died in one of the crash, and that news that news actually spread to America when Otto Lilienthal designed flying wing failed. The Wright brothers took the paper that Otto Lilienthal engineer, the engineer Dr. Otto Lilienthal published, so that they study the data of the Otto Lilienthal wing. And to your surprise, yeah, the Wright brothers has to change some of the information that they have from Otto Lilienthal, and then they continue to develop their own planes. There's a lot of failures. Yeah, either it's fly or lift up for a short while and then drop down. Sometimes it fly for a while and then suddenly they cannot control the airplane. You know, it is whatever that they decide. You know, whatever that they design, the Wright brothers and the whatever that they design just cannot fly properly until 1903, 17 December 1903. That was after so many designs of the Wright flyer. They have to incorporate, you know, a machine in, and then they actually waited for the wind to be strong, and then they actually managed to fly it. But even that also, they have to come up with designing of additional supporting system. Otherwise, they cannot fly as well. So those are the engineers' work that you find problems. You actually become like a jigsaw puzzle. You know, a lot of people run away from problems, right? When they face problems, they just try to ignore it. They try to avoid it, but not for engineers, you know. Engineers, when they encounter problem, it becomes like a puzzle game for them. It becomes like a jigsaw puzzle where suddenly you know, it drives their interest up, and then, how come I never thought about this, and let me solve the problem. How can I solve the problem? Probably engineer A will use method A, engineer B will use method B, engineer C will use method C. But all, you know, despite different methods, all comes into the same result: solve the problem. And that is where the fun of being an engineer is. And I actually enjoy it very much, you know. You know, recently we have a problem, an aircraft problem in East Malaysia, which was actually being stranded. The pilot called back and said, "Ricky, I cannot lift up my nose. Yeah, I have done the trim setting on my aircraft all according to the aircraft checklist. But as I took off just now, I cannot lift the airplane as how it is. It is very, very heavy. It is very, very heavy, but they managed to lift it up and they flew. Yeah, and then they landed in the next destination. So they called, "Hey, Ricky, how? This one, how? We got another three or four more sectors. What are we going to do?" Only an engineer can say this, yeah. Cap, the aircraft is grounded and you cannot fly the airplane. Only the engineers have the authority to say it, not the captain. Not the captain. So of course, I told the captain, "Cap, I'm coming. Yeah, I'm coming over to East Malaysia. Aircraft is grounded. Ask for the passengers and the operations to make alternative arrangement for the passengers. We are coming to look at the airplane." This is a decision and the authority of an engineer. As much as we have fun, we also have a very strong responsibility to make sure that everyone, including the pilot, the stewardess, all of them are safe. No question asked. Yeah, the captain cannot say. Yeah, the captain didn't even tell me, "Oh yeah, why you ground the airplane? No, I got so many flights and I want to come back." No such question one. When the engineer say aircraft grounded, cannot fly, it means that it cannot fly. That is the power, the authority given to the engineer by nature of our profession. That is why I say engineering job is always fun. At the same time, you execute with full sense of responsibility. I always think a person have value because of what? The true value of a person. Is it because of the money that he has only? No. To me, is the amount of responsibility he's able to hold. That is the value of the person. Nothing to do with monetary properties or cars and all those. To me, okay, so that is actually part of the what they call it, the Wright Brothers, how the Wright Brothers came in. And then the Wright Brothers turning point is very crucial, because only after through Wright Brothers can the new development of the airplane comes in. But let you know, yeah, the Wright Brothers are actually dropped out. They did not finish their high school. They were actually drop out. But it is the passion, their interest in getting a flying machine, all the engineering work, all the technician work that's involved, he will get it done. He'll get it done. Yeah. Now, part of the reason why this gentleman here, Daniel Bernoulli, a scientist, yeah, a physicist, I put it here, is because of the Bernoulli's principle that he found, he discovered. Yeah, so you know, without this Bernoulli's principle, the relationship between pressure and velocity of gases, if we do not know, it is hard to actually understand and develop the best airplanes, the best wings that can create the best lift. It's very hard. So therefore, the foundation of this world, the development that we see, the flying machine that we see, the helicopter that we see, even the drone that we see, still lies on the fundamentals of Bernoulli principle. If Bernoulli did not discover it, today we might not even have a flying machine. We might not even have a helicopters. Today we enjoy these kind of things is because of science, because of people, you know, who are involved in science, people who are involved in engineering. And KLESF, Utah, is trying to drive this to share with all the students, especially the younger generation. These are the things that brings value to our life, which is very important in order for the society, for the human being to continue to progress into the future. Yeah, because of Bernoulli's principle, we are able to calculate how much lift that a wing can develop. If we want to increase the lift, what can we do? If we want to reduce the lift, what can we do? If we want to fly high, fly far, what can we do? It's all because of science and physics and engineering. So engineers plays a very, very important role in our life. This is the person that I said, Mr. Otto Lilienthal, yeah, a German pioneer of aviation. He's also an engineer. Developed, you can see from this picture here, from the review of a bird, he came out with the wing design and he flew it. The only problem at that time, he could not control it. Why did Otto Lilienthal die and crash and die? Because at that time there was a very strong gust of wind that blew up his actually lifted up his wing, his glider, and actually because the wind are actually turning, it actually made that thing out of control, the glider out of control, and therefore lost the lift of the wing and he crashed. Now he himself is a mechanical engineer. He himself is a mechanical engineer. Now, it is all about lesson learned. We respect Otto Lilienthal, but at the same time, Where did he go wrong? What was wrong? And who actually overcome the problem? And this is an auto lilienthal. You can see here, it's on top of a hill. Yeah, they even later built a tower so that he can actually glide down. Unfortunately, he crashed and died the next day. Now, who is the person who actually took all the failures of that auto lilienthal and put it into a better perspective? It is actually the Wright brothers. Now they Wright brothers realized that auto lilienthal could not control his glider. He cannot control, just like we are driving our car. Imagine if you don't have brake and your steering wheel does not listen to your hand command, sure gonna get accident, right? Correct or not? So similarly, the Wright brothers put this principle. Now, if I were to fly an airplane, what are the things I need to control? I know auto lilienthal cannot control. Now I know what do I need to control? Because auto lilienthal depended on wind. And wind is a natural thing that flows around. Sometimes there is, sometimes there's don't have. So the wind, auto lilienthal cannot control. So what do Wright brothers do? Wright brothers built an engine, built cast an engine casing out, built a piston engine. Now the purpose of this piston engine is to actually provide lift control. That means just now the auto lilienthal cannot control the wind. Now the Wright brothers can, because why? They're gonna build an engine and they're gonna drive the propeller at the back there. And that is how the first control, the propulsion control, they got it. He learned from auto lilienthal and he designed it. You know, he designed it, he put two propellers, and actually the Wright brothers are very good at their hand skills. They are good bicycle mechanic repairer. At the same time, they are also what they call it, they handcraft their own propeller and they mount the engine that they built into the Wright Flyer. Now, they know now they have a propulsion system. So what the next thing that they do? So they put in controls. What do they control? The pitch. How do you pitch the airplane nose up? So they put on the elevator. So what you see in this picture on the front here, basically is the elevator. So during the Wright brothers' time, not like the airplane today, the elevator was at the front to actually lift the move the airplane up, pitch up and pitch down. The other control that they actually made is actually the rolling. How do you roll the airplane? So they put in the aileron. Aileron is on the tip of the wing. Yeah, but at that time during the Wright brothers, because the mechanical movement of the aileron has been patented earlier, so they actually warp the wing. That means using their waist, yeah, they with a mechanical cable connected. When they turn the waist, the wing will warp. Because why? Because of to meet the Bernoulli's principle. To meet the Bernoulli's principle, the wing that actually warps down will actually get more lift. Whereas the wing that actually warp up will actually less lift. And that is how they get the roll control. Yeah. And of course, the other part that they had is actually the directional control. How do you yaw the plane left and right, left and right? They put in a rudder. They put in a rudder. Now, you see, from the first engineer that failed, now the Wright brothers developed to the next stage. They put on an engine. Now they don't have to depend on the wind outside. They can use the propeller to push the airplane and get the wind to flow over the wing. And at the same time, now they can control the airplane, the Wright Flyer, left, right, you know, roll left, right, pitch up, down, yaw left, right. But remember, this is after many, many falls that they have. And they were trying to look for items that is actually very light. And you can see here, all these here structures here are actually well designed to understand the path of the load when they actually lift are being generated, when the aircraft are being pushed forward. So these are some of the early mechanical engineers purely, very much purely mechanical, and that's it. And this is what formed the basis of the airplane flight until today. These are the fundamentals. That is why the Wright brothers are so important, because they found and discovered the fundamentals, how to engineer an airplane, how to control an airplane. It was only after the Wright brothers successful that we can start flying. You can see the World War I planes, World War II planes, you know, and all those. So this is actually a World War I plane. It actually uses the exact same principle from Bernoulli's principle, exact same controls that the Wright brothers had, except now you can see the propeller, now they mount it forward. Structure wise, you know, it's a different form, but the principle is the same. Yeah. Now, before that, I just move back here. If you look at this, if you look at here, the bottom of this Wright Flyer, actually it doesn't have tire and wheels one. No. It does not have. The initial Wright Flyer, because the engine here is only 12 horsepower, it's very, very small horsepower. I think it's only about the power of about, I think about 15 or 12 whatever bread toaster that we have today. That is the energy that actually can produce. So the power is not strong enough to, you know, accelerate the airplane as how we accelerate today. They actually, at the bottom here, you can see one long pole longerons here, one long longerons here. Actually, it is mounted onto a track, a rail track, where they actually use a weight at the back, mounted on the back, and they catapult this Wright Flyer forward. Catapult Wright Flyer forward, so that actually it can actually fly, you know, get the lift, necessary lift, supported by the engines, supported by the 12 horsepower engines. But by the time you see this picture, the engineers has developed stronger engines ready, stronger engines, stronger flight controls, stronger landing gear, mechanical, still very mechanical. Yeah. Now, the engineers continue to build bigger planes, so they instead of putting one engine like the Wright Flyers or the earlier World War I, now they built four engines mounted on the top, you know, on top of the fuselage, in between the wings, so that actually gave more propulsion power. More propulsion power. The flight controls still remain the same. Whatever there was actually, whatever, a lot of calls on Saturday. Bigger engines, you know, bigger power, but for the flight controls remain the same. And because now you have a much more powerful engines designed by the engineers, yeah, you remove the catapult system. You don't need the catapult system anymore, but you need a long runway. You need a much longer runway. Yep. So you can see from the engineers, they can, you know, from a very bare skeleton kind of flying machine, they actually develop it into, you know, bigger wings, put on the fuel, put on the tires, you know, put on more engines, build a bigger fuselage, and then you can see here, yeah, the fuselage here, you can see the serrated lines. You can see the serrated lines. Can anybody tell me what is the problem? Why do they need the serrated lines? Anybody knows? Now, those of us who have studied engineering before, you will realize that this corrugated fuselage here, the metal piece that we put here, once it's corrugated, you will see that it is actually much stronger. Yeah, it is much stronger fuselage. Yeah, it gives it rigidity, which is strong. Now, this is also another airplanes. You know, when people start to fly, we can see passengers coming in. But we as engineers, when we see passengers coming into the aircraft, people going into the airplane, start trusting our machine, start trusting, believing that what we design will be a good one. What does the thing that comes into our mind as engineer? It is safety. Safety, safety, and safety. Engineers work on the principle of safety first. It's always like that. All engineers, the moment an engineer, yeah, whether it's a mechanical, electrical, electronic, or aerospace or whatever, the moment an engineer neglect safety as the main principle first, it is actually opening the path to catastrophe. So there are times that, you know, engineers have to make very tough decisions, sometimes against the company decisions, that we actually have to actually put aside commercial profit and let's make sure the aircraft is safe first. For example, when the aircraft was grounded, when I told the pilots, aircraft is grounded in Kota Kinabalu and I'll be coming over, our focus now is on the safety of the plane anymore. You cannot, we know it will cause inconvenience to the passenger, it will cause losses to the company. Sorry, as engineers, that is secondary. Engineers always think of the safety first. So today, the car that we drive, you know, even the fan that we use it confidently, right? We use it confidently, right? It's because it's designed by the engineers. And engineers comply to the professional code of ethics. Safety comes first, regardless whether you're from software engineering, whether you're coming from the mechanical engineering or electrical engineering, regardless, it is always, or civil engineering, it is always safety first. Yeah. This is also another example. You can see the airplane, the engineers can build bigger and bigger airplanes, put in more and more engines, but the principle does not change very much from the Wright flyers. Yeah, doesn't change much. This is also the early in the 1920s to watch a movie in flight. Even the engineers have to design an in-flight entertainment system so that the guys, the passengers can view and watch a movie as they fly. But remember, in the early days, the airplanes are actually very, very noisy. And I don't know how they are able to listen to it, but they want to watch movie. The engineers allow them to watch movie, you know. Yeah, they even design the seat, you know. If you look at the picture here, the seat are actually like very old rattan type of seat, right? Eventually the engineers decided design even more comfortable seat. Yeah, the one that we enjoy today in the first class and business class, even economy class, is much more comfortable than this seat law. So engineers, yeah, engineers don't just study and then be stagnant in what they are doing. Engineers continue to develop and improve products. Yeah, electrical system, oxygen systems, do it. This is also another example, yeah, of the entertainment system. At that time, they put on the headset ready. So engineers develop the in-flight entertainment system and communication systems. Yeah. So those are examples. This one in 1938, yeah, this is actually quite a significant change, yeah, compared to the what they call it, the Wright Brothers time. In 1938, Boeing developed an airplane, still a piston engine, still using the 3 flight controls, but this time they put in a pressurized fuselage, which means that our human being, we can normally breathe up to 10,000 feet. Now this airplane, with a pressurization system, the airplane now can go above 10,000 feet. Today we fly up to 50,000 feet. You know, like the Gulfstream aircraft that I'm rated on, we flew at 51,000 feet in US and come back, you know, and come back to Malaysia, you know. So this is at that time that the big turning point was in 1938. Boeing came out with a Boeing 307. The engineers came out with a system that you can pressurize the cabin so that you can maintain a comfortable 8,000 feet, where you can breathe normally, you can eat, you know, you don't have a brain, what they call it, brain impairment and all those. And on top of that, what the engineers did is that they were able to actually make the aircraft fly above bad weather. Why? Remember, engineers safety first, yeah. So now today we actually have a very smooth and faster ride is because of this kind of developments, including the engines, yeah. Now the engines, just now we talk about piston engines. Piston engine has a limitation because piston engine cannot fly high, correct? Because piston engine just stick in the ambient air. Even if you put on the what they call it, the turbocharger or supercharger to compress the air before it goes into the combustion, but there is still a limitation. So this gentleman here, Mr. Sir Frank Whittle, He actually looked at the problem. Again, there's a problem, right? As an engineer, he find a solution. So he came out with the gas turbine engine. Sir Frank Whittle came up with the very first gas turbine engine, and that was the engine that make the airplane change in from a piston era into the jet, gas turbine jet engine era. And that is actually what most of our airlines flying today. All our jet engines, commercial are all gas turbine jet engines. Okay. Now earlier we also have analog systems. Now this analog system means that it's very mechanical. We have not gone into digitalization first. So in the beginning of 1900s, 1903, even up to the 1970s, 1970s, majority of the systems are still using the analog system, cable operated, very mechanical. Even autopilot system at that time also pretty mechanical, quite mechanical. Actual autopilot actually existed in the year 1912. Engineers who actually came up with this smart idea that, if the airplane fly, how do you know that, to maintain the straight and level flight? You cannot be holding the control column from Kuala Lumpur to London, 12 hours flight. The pilot cannot be holding the control column just like that, correct now? So they incorporate an autopilot system. Now this autopilot system, they uses more complex, which is actually the gyro system to actually ensure the airplane can stay straight and level flight. And also for the commercial airplane from the 1950s onwards, it is not no more just one pilot or two pilot. They put in the flight engineer and also the radio operator and also the navigator. So the earlier planes like the one that you see just now, they have two pilots, one flight engineer, one radio operator, and one navigator. Problem, right? Every time want to fly one flight, have to have 5 people to fly. Problem, like, instead of paying instead of instead of 2 pilots flying, the 3 is occupying the space, which can be sold as a as a passenger seat, right? So now who solved the problem now? Engineers now? Okay, all right. Let's do something. So they came out with the autopilot system, the automation system, the navigation systems, all actually remove the flight engineer, the radio operator, and also the the navigator. So now the pilots can have all the systems under their own control easily, all designed by the engineers. So this is a very old airplane. I won't say old, but at least 40-50 years old. This is actually a 737-200 cockpit. Very much you can see it's very mechanical. Analog system. You might have digital system, but it is still very, very limited. Very limited. Now this is a 737-400 where I'm rated on. You can see this came in the 80s. You can see now it is going into from the analog system is going into the digitization. Digital, you can see the glass cockpit start coming in ready, but you still have a lot of switches. You still have a lot of switches, but you start seeing the monitors and then the digital scale and all those. This is what we have now, and this is the aircraft that I'm rated on. You can hardly see any switches. Why? Because we have entered into the digital era, where now a lot of engineers are converting the mechanical systems to be integrated into the digital systems. So therefore, actually the digital engineers are very, very electronic engineers also plays a very important role nowadays. Initially during the airplane design, mechanical engineers important. Today the mechanical engineers are also important. Now they have to move into more of digitalization. Now, when we put the aircraft into automation, when we digitize the airplane, there is a risk. The engineers have to be very careful so that there is no over automation. Now, what does it mean over automation? When there is over automation, that means the automatic system takes control over the pilot. And that is exactly what happened in the Boeing, in the very recent 737 MAX crash. The JT610 and the Ethiopia Flight 307 is a very classic example where if the engineers are not careful enough in designing automation system, you realize that the automation system takes over the pilot and the pilot cannot control it. Just like what happened on these two flights, the system automatically keep the nose down all the while, even though the pilot was trying very hard to pitch up the nose of the airplane. They couldn't, because it is overriding pilot, the system overriding pilot, until the aircraft crash. This is an example where the engineers have to be very careful, to ensure the pilot is always in control. Any automation system on the airplane, the pilot have the control and disconnect the automation and fly manually. After the 737 MAX crash, one of the biggest improvement that they have done on this airplane is actually let the pilot override the MCAS system. The pilot can just disconnect it, and the pilot can overtake the flight of the flight. Yeah. So this of automation, engineers also have to look into it. So to me, it's a lot of challenges that makes our job as engineer very interesting. There's a lot of challenges. There's a weather challenges, there are material challenges, there are power challenges that actually when we sit down and design an airplane, whether it's a systems or whether it's a power plant system or a navigation system, we realize that whatever that we decide makes an impact to the safety of the airplane. And therefore, responsibility comes in, and that actually creates value as a human being and also as an engineers. Of course, our engineers, most of them are very good. Airplanes are still one of the best and the safest way of travel on the record, even till today, thanks to the engineers. Yeah, I'm talking about not just aerospace engineers. Yeah, mechanical, electrical, electronic, chemical engineers, all of them, one way or another, they were involved in the development of the aircraft. Okay. Now, however, this is the new, we are talking about the future now. Engineers also have to overcome the limitation of gas turbine engine, and this is very much on the sustainability issues. Gas turbine engine is powerful. Yeah, gas turbine engine can produce one engine itself, like the Gen X engine. Yeah, can produce 100,000 pounds per engine. If you have two engines, you have 200,000 pounds. That is extremely powerful, but there is still a limitation. Why is there limitation? Because of sustainable development goals. Gas turbine engine uses fossil fuel, and fossil fuel pollute the environment. So now the airplane has developed to come to a stage where we get the machine flying. Yeah, we have the system, we have the comfortable of the passenger can fly comfortably, we can fly high and safely. But then we have an issue, another issue, the environmental issues, sustainable issues. There's no much, we have no more resources. Our resources of fossil fuel is limited, and we are polluting the environment. Now, who solved the problem? Engineers law. Yeah, engineers law. So now the engineers now has to move to another era. We are talking about electrical propulsion system, which is some already been developed, some are actually being developed. Depending on what type of system. We are talking about hydrogen fuel. Now, we also talk about ionic propulsion system. This does not produce contaminants and pollute the environment. You see, the interest of the engineering is interested is move on to one stage and one stage and one stage, and we are the problem solvers, just to make sure that the humanity has a better place to stay and has a better flying machine, safer flying machine, So these are the role of the future engineers that we are talking about. Number one, in the aircraft development, we also have to look after the social and economic development. Yeah, you cannot simply design planes using heavy metals. You keep digging the getting the aluminum, or getting steel and all those, to build the airplanes, heavy airplanes. No, we have to come up with new methods of manufacturing, new methods of design, new metals or material to be used, composite and all those. Yeah, because we have to also think about social and economic impact. Climate change, I've mentioned about it just now. Now, the other thing is that the noise that's produced by the gas turbine engine is so noisy. We have to find ways to reduce the noise of the engine, the local air quality. We are talking about air pollution just like just now. We also have to ensure the surface access industry. That means the ground industry are also being protected by our design of our plane. And of course, natural resources, environment. We have to effectively manage, use material that is necessary, materials that is actually damaging to the environment. We do not want to use it. As engineers, we are responsible. And then implementation of full industry commitment to the sustainable development. The world is not just the engineers' world, We have so many people, the bankers, the academicians, the business people. We actually have to come up with a system to make sure that whatever that we design, whatever we develop, whatever that we maintain, does not do harm to any of these people. It's our natural responsibility, and we feel proud of it. Now, these are some of the airplanes, electric aviation airplanes that I'm trying to share with you all here. Very futuristic. It's been tested ready. Entry into is using electrical systems, no gas turbine, pure electric motor and fan and all those. Entry into service 2025 in Germany. Mechanical engineers, electrical engineers, aerodynamics engineers. This is also another plane, very competitive. This airplane actually fueled purely electric. Using a battery power, lithium-ion battery pack. Very powerful, has been tested. Expect to go into service in 2 years. And this airplane costs about $3 million. $3 million. Worth it, These are some of the planes that we can see in the future. We need a lot of engineers. So I encourage all whoever the students here, take up engineering, take up your science subject, and then plan yourself to be the engineers of the future, because these airplanes, what you see on this scale here, on this slide here, it is very much on the still under development stage, at the infant stage. We need more engineers to come in and actually to develop them, to improve them. Maybe by the time you come up with the best models of what you see here, I might not be around anymore, but we lay the path and then continue to encourage the engineers to move on. Now, characteristics, what are the characteristics of engineers of the future? We talk about Elon Musk, right? We talk about Michael Faraday, we talk about Jeff Bezos and all those. These are all the engineers. These are all the engineers. But there are certain traits that they have that we also need to build it within ourselves. Number one is passion in engineering. Don't study engineering because your parents ask you to. Don't study engineering because it is a glamour to be an engineer. You study engineering because you have passion in engineering. You know you want to support the people in the world, and we take it as our responsibility. Because we have acquired the knowledge that other people don't have. We have the understanding of the system and technology that people don't understand, we can understand. Have you ever talked to an accountant before about aircraft systems? Oh, I spoke many times. I got a big problem trying to make them understand. Okay. So the other thing is a high level of curiosity. You always want to learn. You always want to seek to improve yourself. You are creative. You're innovative. You like problem solving because it's just like a solving puzzle. You have also good soft skills, including communication and leadership, and a team player. Remember, we cannot design the airplane alone, The airplane itself takes thousands of engineers, for 747, even the Gulfstream G500, we talk about, thousands of engineers to actually get involved from every detail of the aircraft. Mathematical and analytical abilities, you need to have that. You need to actually have a pretty good foundation in mathematics, yeah, and able to analyze, yeah, things, yeah. When you see something wrong, you don't look at it at the surface. You dive into the system and go into the, probably sometimes into the quantum level, yeah, and try to understand why things fail, you know. And the other thing is that logical thinking, yeah. We thought logical thinking is easy, right? But actually it's not easy, yeah. And then attention to detail. These are the characters that engineers need to have for the future. Yeah. I hope, yeah, I hope through this presentation here, I hope that the participants here will get an idea about, you know, the engineers of the past, present, and the future, and make a decision, you know, to embark in this field. You know, to me, I think we need a lot of engineers in Malaysia as well. Now, this is how Albert Einstein, yeah, this is a conclusion slide. This is how Albert Einstein looked at the engineers. How much, from here, you can see how much Albert Einstein respect the engineers. And this is his statement: scientists investigate that which is already is, but engineers create that which has never been. This is how much Albert Einstein respect the engineers. And we, all of us, should be proud of us. Doesn't matter whether you're engineers, whether you're engineering technologists, whether you're engineering technician. You and me, we are all in a team, and we have to make a better future for our generations to come. Be part of it. Be proud of it. Yeah. Okay. That's all. That's end my presentation. And I hope, yeah, I hope you all get a slight idea. My presentation is very focused and from a one single perspective. There are a lot of things about aircraft development. There's so many things, and I cannot actually put it on the slide in just this 1.5 hours presentation. So thank you very much for your participation, for your attention, and let me pass the floor to Lee again, Miss Lee again, and then to see if whether there's any question from the students or not, or the participants or not. Thank you so much. Over to you, Lee.
Thank you. Okay, dear all participants, if you have any question, you may post it at the chat box. Okay, so while waiting for the question here, I have gathered some of the questions from the registration. So let me paste the question here and read it out for our engineering team. Okay, so the first question received is, in terms of economic feasibility, is supersonic commercial jet a possible idea in near future?
Thank you for the questions, whoever was asking these questions. Yeah, definitely the supersonic commercial jet is feasible in the future. Sorry, so many calls today. Attend to the calls after I finish this session. Okay, supersonic commercial jet is definitely feasible. In fact, there are new developments, yeah, new developments in the US at the moment. They are developing the prototype. Now, this commercial jet will be very much improved, yeah, compared to the Concorde commercial jet that we have last time. Concorde last time is prohibited, yeah, from flying into certain areas because of the sonic boom it created, and that also has placed restriction to the Concorde where he can fly and all those. Now, this new supersonic jet that is under development has managed to overcome some of the problems associated with the sonic boom. That's number one. Number two, the material used to create the fuselage, yeah, is a much better material. And if you look at the Concorde jet, yeah, one of the material that they use, highly used in the Concorde jet, is actually the titanium. But titanium is actually very expensive, you know. So the new supersonic jet will have a different material, yeah, that can actually withstand the heat and the temperature under the high operational speeds. And in fact, the electronics technology that we have today, in terms of the way we fly a supersonic jet and all those, it is actually much more developed, much more advanced now. which actually have to overcome a lot of problems that we have with the Concorde systems. So definitely it is one of the, I would say, one of the luxury option of the luxury commercial passenger in the future. It's feasible, yeah, it's feasible. Yes. Okay, I have a second question here. How can one apply knowledge, yeah, from the aircraft field to automotive field, particular race car aerodynamics? I think aerodynamics, whether it's in a race car or in the what they call it, on the aircraft, yeah, there is a lot of similarity, yeah, similarity. At the moment now, I think by the speed of the race car that we have at the moment, it is, the material wise, it is actually quite sufficient, yeah. Still can be improved, but it's sufficient. But now the issue is, how do you maintain, yeah? How do you maintain the reduce the drag of the airplane, the drag of the aircraft, the racing car as much as possible? I think that is a challenge, number one, yeah. Number two, the tires contact surface, onto the ground. Either you grip the ground hard, you bite the ground hard, or you minimize reduce the friction contact between the tires and the ground. How do you do that? Now, I always have this thing. If you have watched, if you have been following the scientific development in various technology, if you watch the Iron Man, one of the Iron Man movie, yeah, you remember Tony Stark's father, he displayed a car and then he removed the tire, and then the whole car was actually floating on the stage. That is actually possible, and in certain extent, it already been done, which means that there is a lot of room for development of, you know, anti-gravity technology. It is there. It is there. So are you able to actually remove the wheel assembly? You're basically floating and apply it into your race cars. And as a matter of fact, can you even apply it to the airplanes? Yes. So these are all the areas that I think by applying this knowledge and technology that we have a long way to go. We can actually make it eventually, and you can adopt it both in the aerospace industry as well as the automotive industry. That's all I can say, you know. But I'm very fascinated about anti-gravity technology because certain communities have it, certain scientific communities have it, but certain people actually don't have it. They keep it from other people. Okay, next questions. That much I can answer for that one.
I just listed another 3 questions I received from the registration. So is build an aircraft hard?
Is building an aircraft hard?
Yes.
I would say that it depends on what type of airplane. You want to build a simple plane where you can actually buy a kit and then you actually what do you call it? You can buy the airplane and then you can just build it up. And I have some of my friends who actually have built it before. But if you're talking about complex aircraft, complex multi-engine airplane like the 747, you know, like those airplanes, it is not easy. It is really not easy because complex machine require a complex mechanism, digitalization, and also a lot of what they call it, a lot of systems of monitoring and all those. So actually it is quite complex, but it can be done. Yeah, it can be done. We can fly to the moon and Mars. I mean, what about, you know, a plane today? You know, we even have a flying machine that actually flew 500,000 miles or million of miles to a galaxy radius. I'm sure we can do it. Yeah. Is electric commercial airplane possible to reduce carbon footprint? Yes, definitely. In fact, that is the direction of the commercial airplanes is going through. Of course, they did announce it, but of course, their primary operation is still using the fossil fuel as the primary source, yeah, of energy, yeah. Electric commercial aircraft definitely is gonna reduce the carbon footprint. Will aviation industry will move forward and adapting more advanced technology which open up more job scope? Yes. The engineers that we have last time and the engineers that we have today have been actually advancing themselves, yeah, has been advancing themselves. Last time we are very mechanical, but today we actually have to study electrical and electronics, yeah, and the specific courses that we actually make sure that we have to pass to actually continue to move forward. So as advance in technology develops, so are the engineers' syllabus and the contents. Yeah. So it's very important if you're an engineer who graduated last 30 years, yeah, we have to actually continue to actually update ourselves and study ourselves. But knowing human character, sometimes, yeah, sometimes we only, we only go to work only, right? We only go to work and then get our jobs done and then we come back, right? So that is where the importance of getting involved in professional society, learned society, that actually requires you to actually update your knowledge continuously. For example, if you're a professional, certified professional engineers, every year, yeah, every year we have to have 25 hours of continuous professional development hours. We need to have it, and we need to show it to the what they call it, to the board, yeah. And how do you do it? Is through giving talks like this, reading up, doing presentations. These are all that can make us to continue to improve ourselves. So if you are an engineer, it's important for you to go for professional certification, because professional certification, I would use the word force you actually to continue to study and learn about your field. Yeah. Now the last part here, this is actually from TS Siva. Thank you. Yeah, TS Siva all the way. Yeah, tuning in all the way from the Middle East at Etihad. Yeah. Developing long-lasting batteries and engine with no rotating wheel are the challenges in terms of energy and propulsion. TS Siva is very right. Yeah, he's very correct. Yes, we have issues in developing long-lasting batteries. We have issues in developing engines with no rotating parts. Yeah, guys, the younger generation, you are the ones who are going to make and solve this puzzle. Yeah, I will interested to solve this puzzle as well, but my time is limited. Therefore, the younger generation who are participating today, please get yourself indulged in engineering, get good at mathematics, get good at physics, be an engineer, solve the puzzle. Challenging, right? Life will always have an objective. Okay, that's all I have, Lee.
Yeah, there's no question from YouTube, so probably we wait for another minute. But before that, I would like to post the sign out form and feedback form for participants to fill in after webinar. Then okay, can I have a request? Let us take a group photo here. Participants, you may turn your camera on. Yeah, and Engineer Ricky would like to ask you to stop sharing the screen first, then we can take the photo.
Okay, I'll stop sharing.
Okay. Participants, get ready. It's okay if you cannot turn on your camera. Maybe you just at the reaction there can give us a thumbs up. Okay, so okay, we take a few shots. First one first. Okay, 1, 2, 3. One moment. Again. Okay. Okay, the photo is good. Thank you.
Okay, thank you so much. Yeah. Thank you.
Mr. Ricky,
yes,
I have one question.
Yeah.
Okay, if I invite you for a seminar talk or a small short talk in schools, do you do that?
Can just probably I'll just put my contact here.
Please. I'm also my boy is in MBS KL as well.
Oh, MBS KL.
Yes.
Oh, my school. Okay,
Yeah.
sure. Special session.
Thank you. I can talk to my principal as well.
Yes, definitely. Okay, I put my my contact number in the what do you call it, in the chat box. You can take up the number, and then later we can communicate on the site lah. Yeah, I definitely come to MBS KL lah.
Thank you so much, Mr. Ricky.
Welcome. Yep. And anything else?
There's no question for now. In case any of the participant, if you have any query or you would like to contact Mr. Ricky, you can let me know. So you can drop message to KLESF, then I will get back to you.
Okay.
I guess there's no other question. Once again, I would like to say a big thank you to Engineer Ricky for this insightful webinar. I hope this webinar can inspire our students, our participants, like not only how to be an engineer, like you can apply the values and the characteristics that mentioned just now in our life. So hope everyone learned something new today. And thank you for everyone time for today. Now sorry for delay after some technical issue just now, and now extend another 5 minutes. Okay, so there are some text or say thank you.
Yep.
Okay, so we would like to end our webinar now. Thank you.
Okay, thank you.
Thank you, Mr. Ricky. Thank you.
Thank you. Bye-bye.
Thank you.
Bye.